All right, I hope you've had an opportunity to try out this problem on your own. I'm going to walk through the solutions now. So we are continuing to work with hydrogen cyanide, and we've already calculated the Ka to be 4.8 times 10 to the negative 10. And this will be the Ka value regardless of the concentrations that I start with. And my equilibrium concentrations will always equal this Ka value. So we're going to look at this now with a new set of conditions. And we're starting with a hydrogen cyanide concentration of 9.5 at equilibrium. So the first thing I'm always going to do is write out my equilibrium constant expression. So Ka is going to equal my products, which is my cyanide ion, times my hydronium ion, divided by my reactants, which is HCN. I can now plug in what I know. I know that I have a concentration, or a Ka of 4.8 times 10 to the negative 10. And I know my concentration of hydrogen cyanide is 9.5 molar. And then I have my concentrations of cyanide and H3O+. Now, here is the one thing. Because this reaction is 1 to 1 to 1 to 1, meaning all of my coefficients are 1. For every 1 molecule of HCN that undergoes an acid-base reaction, I get 1 of each cyanide and H3O+. So these concentrations will be the same. So I know that the values of these numbers are going to be exactly the same. So I can assign a variable to them, call them each x. Well, that's really equal to x squared then, 9.5 molar. So now I have something I can solve for. And this x is going to be equal to the concentration of cyanide, but it's also going to be equal to the concentration of my hydronium ion. And that's really what I'm interested in here, because with my hydronium ion, I can calculate the pH, which is the question, which will be the negative log of that H3O+ concentration. So solving this, I'm going to multiply both sides by 9.5, which is going to give me a value of 4.5619 times 10 to the negative 9. It's equal to x squared. I'm now going to take the square root of both sides, and that squared and square root will cancel out. So x will be equal to the square root of that value, which is 6.75 times 10 to the negative 5th. So this number here, in molarity, is equal to my H3O+ concentration. Now, knowing that, I can calculate pH. My pH is going to be equal to the negative log of my H3O+ concentration, my hydronium ion concentration. So that'll be equal to negative 1 times the log of 6.75 times 10 to the negative 5th, which if I plug that into my calculator, will equal 4.17. And that is my pH.